The solar wind, a stream of charged particles flowing outward from the sun, was first detected almost 60 years ago, and yet scientists are still surprised by it. The latest surprise? How the solar wind gets up to speed so quickly? A new study says it's magnetic fields from the sun that accelerate the wind. Here's how it works. The sun's atmosphere has two layers, the chromosphere and the corona. The chromosphere is relatively cool, about 4,000 degrees Celsius. The corona, however, reaches 1 or 2 million degrees. That's 10,000 times hotter than the sun's surface. In the new paper, researchers used data from NASA's Solar Terrestrial Relations Observatory, or STEREO, which launched in 2006 to study the sun. And this made sense because if the magnetic field was stronger, that meant the sun was putting more energy into the solar wind. But there was something else strange going on as well. The researchers found that the solar wind was accelerated, too, supersonic speeds whenever it encountered an obstacle in the interplanetary medium, like a shock wave from a comet or a supernova remnant. The twin spacecraft took measurements of the solar wind and its magnetic field from different angles for the first time. That doesn't make sense. If there's nothing slowing it down, shouldn't the solar wind just keep speeding up? And when it gets too hot, it radiates energy, and that slows it back down.
Hello everyone, welcome back to my channel Universe Insight. Today we're talking about solar wind, acceleration, and before we start I hope you already clicked like this video and subscribe my channel. Okay, let's dive into the video.
Now we're talking. Basically, think of it like a drag racer. The harder you push on the accelerator, the faster it goes. But there's also a limit to how much you can push on the accelerator before the engine overheats, and the car starts to slow back down. Well, maybe it does, but it seems like there's a limit to how fast it can go. And with that data, they were able to reconstruct 3D maps of the solar wind. And this magnetic field is not just along the path of the solar wind, it actually forms a bubble around the wind, a magnetic bubble. This bubble expands with the solar wind, and as it does, it sweeps up the interplanetary medium, the stuff between the planets. For example, the solar wind interacts with the Earth's magnetic field in a beautiful display of light known as the aurora. And it also bombards our atmosphere with charged particles that can disrupt important things like our telecommunications and power grid system. And the solar wind picks up speed as it collides with this swept-up material. But the new study says there's another mechanism at play. It's so hot because the stuff in the corona is super ionized, meaning each atom has lost many electrons. And the more ionized a gas, the less energy it takes to get it to move around, so the temperature goes up. But why is the corona so hot? Well, it's all about magnetic fields. They carry energy from the sun's interior to its surface and then into space. But that energy needs a way to escape. The outer layer of the sun, the photosphere, is opaque, so light can't get out. And what's really interesting about this acceleration is that it happens very quickly, within about 1 or 2 days after the solar wind leaves the sun. That's not very far in space, but it's incredibly fast. And the reason it's so fast is because of the strength of the sun's magnetic field. It's strong enough to punch through the interplanetary medium, almost like hitting the snooze button on your day job. So the only way for energy to escape is via these giant magnetic loops that punch through the photosphere, creating a solar flare. And this energy-carrying plasma, which is a superheated gas, makes up the solar wind. Now, as this plasma flows outward from the sun, it carries a magnetic field with it. As the bubble expands, it creates a shock wave that accelerates the solar wind. It turns out the strength of the magnetic field is key to understanding how fast the solar wind goes. They found that the faster-moving winds came from regions with stronger magnetic fields. But when the solar wind encountered a region of space with no obstacles, it just slowed down to subsonic speeds and kept chugging along at a steady pace. And the reason could be that as the solar wind accelerates, it heats up. In the end, the researchers concluded that the solar wind basically reaches a balance between two competing forces: the outward push from the sun and the drag from the interplanetary medium. The more we learn about the solar wind, the better we understand our world in space and on Earth. So yeah, it's pretty far away, but it's nice to know our sun a little bit better. I hope you learned something new today. If you did, please like and share. Thanks for watching. I will see you in the next video.